Let's go through LeetCode 1443. Minimum time to collect all apples in a tree. And for this question, it gives us a tree. The tree is giving us an age, right? So for the node, it may have multiple child. And it says that it gives us a number, and also it has an size and list, which is a Boolean type, which will indicate for the node n I whether it is an apple or not. So it asks us to find the minimal time to collect the apple. So let's look at this example. And also the question says that the root, it is always collecting from the node 0, right? I think yeah, at vertex 0. So we can consider this tree the root. This is the root, okay? So let's look at this example. So this one is an apple, this is an apple. So you need to go to this kind of path, this kind of path, this kind of path, this kind of path, this kind of path to collect the apple. So the total time is 1, 2, 3, 4, 5, 6, 7, 8. So it returns 8. So what we're thinking about is that for tree node, right? It has multiple child. So the thing is that if in this child, okay, for every child, we probably we can write a DFS called minimum time to collect DFS for this node. The meaning is the minimum time to collect all of the apples for this node. Okay. So we know there are several scenarios. That is, for example, if this kind of node, we return greater than 0, right? That means there must have apples in case this child. So when we calculate the contributor to pick up it's the apples in this branch, we just add 2, right? Just add 2. So no matter this is an apple or not. Another scenario is that this child is a leaf. Another example is that so if this DFS returns 0, we just plus 2, right? So another scenario is that if this one we DFS get equals to 0, it has 2 scenarios. One is that it itself it is apple. So if this DFS equals 0 and this is apple, we should add 2, right? And if it's not apple and this is for this tree, it returns 0, then means for this child, we don't need to contribute to any apples. So we'll add 0 for it. So in this case, we do the post order traversal from the leaves to the parents, right? So one of the things we want to mention is that from this age, we can create a graph that is map, right? Map integer for the list of integer, right? So every node it will put the connected vertex into this one. So when we do DFS, we should pass in the parameter which is called parent, right? So that if its neighbor is its parent, we don't need to calculate. We just calculate its child. So let's begin to write code for this. Firstly, we need to compose the graph, that will be map integer list of integer equal graph equals new hash map. And for every age, we compose the graph, the map, right? So that is graph compute if absent age 0. K goes to new array list, okay? And we need to add age 1, okay? And this is bidirectional, so we have this one as well. So we compose a graph here. Then what we need is that we'll say because it says that the start from vertex 0, that is the parent, right? So we just return DFS current 1. Let's put -1 as parent. And graph, and also we need to have the has apple, right? So let's write that DFS we return for current node the current vertex or node, right? Current node, how many, the minimal time to pick up the apples current, and this kind of things as graph, right? And we need has apple, right? Okay. So the first thing we need to check is if this graph does not contains key current, doesn't contain just return 0, right? Because it will not have any child, and there does not have any connected age. Then for every child, okay, in current gate graph. Okay. So this child actually, it is possible that it's its parent. We can call it a neighbor, right? So if it is because of what we compose this graph, it's just get its connected age. So let's say if this child, if was parent, we should continue with, right? Continue. Then we'll say for every then we'll say for example, of every child we have child result, okay? Child result equals PFS child, and parent is current, and graph, and has apple, right? So there are several scenarios. Is that if current result is greater than 0, right? So we'll have a result here. Input result equals 0. We'll have result plus equal to current result plus 2, right? And let's say if current result equals to 0, and if it's it is an apple, that is has apple, it is a leaf, right? Has apple, current result equals to 0. Let's say okay, excuse me, I just check my words. This one doesn't say it is a leaf for this kind of scenario, right? We'll say it also return 0, right? And we'll say if for this node, this child node, it has apple, It's not necessary node, right? If let's say if this one also returns 0, but this node, this child node is an apple, it contributes to its parents should add +2, right? So no matter whether this is live or not, we don't the live is useless. Okay, so we treat so if has apple let's say child, then like that's the result that's equal to 2, right? And then in the end we get the return result. For int cannot this is not current. Okay, should be graph get current. And has this is a list, right? Get child equals equal to, right? Okay, so this is a post order traversal, so the time complexity will be O n. We traverse once.